Hey guys, and welcome to the Shack. Today's video is going to be a little different than normal, and that's because it's part of a chemistry project for school. What I'm essentially going to do is give you a tour of all the different types of matter that we have here on this place called Earth. We need to first start by defining matter. Matter is anything that has mass and volume, or in other words, anything that has mass and takes up space. The matter we are most familiar with consists of atoms, which are made of electrons orbiting a nucleus. That nucleus is made of two types of hadrons, protons and neutrons. Those protons and neutrons are in turn made of quarks held together by gluons. While there are many other fundamental particles that we encounter on a daily basis, such as neutrinos, we are most familiar with matter composed of atoms, and that's what we will be classifying today. Within the category of matter, there are two major subdivisions, pure substances and mixtures. Pure substances are just what they sound like. They are made of one material not mixed with anything else. Mixtures, on the other hand, contain many different substances that are physically but not chemically combined. Within the category of pure substances are elements, which are the 100-some symbols found in the periodic table, and compounds, which consist of two or more elements in a chemical bond. Some examples of elements are carbon and magnesium, and some common compounds are water and table salt. There are also two types of mixtures, heterogeneous and homogeneous. Heterogeneous mixtures have distinct regions with different properties, such as duct tape and vinegar. The components of a heterogeneous mixture can easily be separated by physical processes alone. On the other hand, homogeneous mixtures are uniform in property throughout. Every region has the same components, density, chemical and physical properties, etc. Any chemical solution, from bleach to hydrochloric acid to Kool-Aid, would be considered a homogeneous mixture. Alright, now that all the boring definitions are out of the way, I would like to demonstrate the differences between all of these categories of matter by showing copper metal changing between the four groups. We start out with copper sulfate, also known as cupric sulfate. This is a compound as it consists of copper ionically bonded to sulfate, and the sulfate in turn consists of sulfur covalently bonded to oxygen atoms. In its natural form, it is a boring white salt. The reason this copper sulfate is blue is because the crystals have water molecules trapped within them. The water, along with a bunch of quantum mechanics mumbo-jumbo, makes the crystals appear blue. So, on a very technical level, you could say that this is a mixture, as it consists of two compounds. While the water experiences attraction toward the ions of the copper sulfate, it is not chemically bonded with them. For our purposes, however, this represents a compound of copper. Anyway, now I will dissolve the copper sulfate in water. We now have a solution, which, as stated before, is essentially a synonym for homogeneous mixture. The copper sulfate has dissolved and been split up into ions, which have distributed evenly throughout the water. Once the copper sulfate is completely dissolved, I will take the solution and add it to another homogeneous mixture consisting of calcium chloride dissolved in water. Immediately upon addition, a heterogeneous mixture is formed. We have a green solution clouded up by a white powder. What happened was a simple double displacement reaction, or metathesis reaction, where the copper ions traded places with the calcium ions. The result is a green solution of copper chloride and a white, so-called precipitate of calcium sulfate. The calcium sulfate does not dissolve in the water because of its very low solubility. To prove that this is indeed a heterogeneous mixture, I will separate the solution from the precipitate via filtration. Now I will take this solution, or homogeneous mixture, of copper chloride and water, and add aluminum to it. Aluminum is an element, one of the categories of pure substances. Because the aluminum is more chemically active than the copper, it will trade places and produce a clear solution of aluminum chloride, and as you can see here, pure copper metal. After the reaction is finished, we have a heterogeneous mixture consisting of a homogeneous mixture, the aluminum chloride solution, and an element, copper. Finally, a quick filtration leaves us with the pure element, copper metal. So, to recap, we started out with a compound of copper, and then turned it into a homogeneous mixture. We then combined it with another homogeneous mixture and ended up with a heterogeneous mixture. After separating the solution part of the heterogeneous mixture, we added the element aluminum to it. This created another heterogeneous mixture composed of copper metal, aluminum chloride, and water. Finally, we filtered the mixture and were left with the element copper. I would like to end with an important note on safety. While this demonstration appears to be without risks, the copper compounds used are toxic, and the copper 2 chloride solution is extremely corrosive. Do not repeat this yourself unless you are an experienced chemist and/or have appropriate supervision, and wear proper PPE to limit your exposure. Well, thanks for watching. Please rate, comment, and subscribe.